Okay. In the previous lecture, we seen that what is the existent criteria for irreducibility of polynomial over the field of hmm, rational number. Okay, Q. What is the statement? That P belongs to Z where any prime number. Let f of x belongs to Z of x. Okay, where Z is set of integer, ring of polynomial over integer, where f of x is equal to a naught plus a1x plus a2x square up to so on an x raised to n, where an is not equal to 0, such that an is not congruent to 0, 0 mod p. What is the meaning of this sentence? P divides, does not divides an. Okay, and where p is the prime number such that p divides a naught, p divides a1 up to so on that p divides an. Okay, and p square does not divides a naught. Okay, so if this condition satisfy by any polynomial, well, then the polynomial p of x is irreducible over q. Okay, now today we will discuss what is the cycloatomic polynomial. Have you solved this example?
Yes, sir.
Any problem? Kite outside catcher.
No, sir.
Okay, so f of x is irreducible over q here. Okay, we will see what is the cycloatomic polynomial. So it is the one type of polynomial that polynomial is called as cycloatomic. एक नाव दिले त्याला आपण. Okay, now look at it. Cycloatomic polynomial. The cycloatomic polynomial. Okay, now let phi p of x, which is equal to x raised to p minus 1 divided by x minus 1, which is equal to x raised to p minus 1 plus x raised to p minus 2 up to so on x plus 1, and that polynomial is called as cycloatomic polynomial. Okay, so this polynomial is irreducible over q for any prime p. ओके, याचा अर्थ काय? हा जो पॉलिनॉमियल आहे की नाही, x रेज टू p मायनस 1 प्लस x रेज टू p मायनस 2 अप टू सो ऑन प्लस x प्लस 1, या फॉर्म मध्ये जर कोणता पॉलिनॉमियल असेल वेर p इज प्राइम नंबर, देन दॅट पॉलिनॉमियल इज irreducible over q. For example, take p is equal to 5. Okay, so what is the cycloatomic polynomial? 5p of x what? X raised to 4 plus x cube plus x square plus x plus 1. Okay, if p is equal to 7, then what we get? 5p of x is x raised to 6 plus x raised to 5 plus x raised to 4 plus x cube plus x square plus x plus 1. So this polynomial also irreducible over q. Okay, for any prime number p. Okay, now look at the proof. We know that if f
सर
of x,
काहींना जॉईन होता येत नाहीये.
काय
काहींना जॉईन होता येणे.
उशिरा केलं असतं. Wait. Okay. Okay, we know that if f of x is irreducible over q, then f of x plus 1 is also irreducible over q, if and only if. Okay, we proved in the previous lecture. Okay. The remarks are there some. F of x is irreducible if and only if f of x plus 1 is also reducible. So what is the counterpositive statement? Negation of this one is f of x is irreducible. It implies and implied f of x plus 1 is irreducible. Okay, but instead of x plus 1, we can take any constant x plus 2, x plus 3, x plus 4, x minus 1 also. Okay, So here what is the phi p of x? Phi p of x is equal to x raised to p minus 1 plus x raised to p minus 2 up to so on x plus 1. Okay, हा तुमचा काय phi p of x, x raised to p minus 1 upon x minus 1. Okay, now look at the proof now. Now, let g of x is equal to phi p of x plus 1. Okay, what is the phi p of x? X raised to p minus 1 upon x minus 1. Okay, so what is the phi p of x plus 1? Put instead of x here, in place of x is x plus 1. So what we get? X plus 1 bracket raised to p, okay, minus 1 as it is, divided by x plus 1 in the bracket minus 1. Okay, so what we get here? X plus 1 bracket raised to p minus 1 divided by plus 1 minus 1 get cancelled. So here denominator is only x. Okay, how to expand the x plus 1 bracket raised to p now? Suppose this is 6. Okay, x plus 2 bracket raised to 6. How we are going to expand this? 6c0 x raised to 6 and 2 raised to 0 plus by Leibniz द्वारा, okay, 6c1 x raised to 6 minus 1 5 and 2 raised to 1 plus 6c2 x raised to 4, okay, and 2 raised to 2 plus 6c3 into x raised to 3 2 raised to 3 plus 6c4, okay, x raised to 4 into 2 raised to, sorry, dealing x raised to 2 and 2 raised to 4 plus 6c5 into x raised to तर किती झालं इथे 3 4 2 सॉरी 1 into 2 raised to 5 plus 6c6 x raised to 0 and 2 raised to 6. Okay, so this is the expansion of x raised to 2 bracket raised to 6. Okay, by which rule? This Leibniz rule. Okay, well, similarly, we are going to expand x plus 1 bracket raised to p. Okay, हे लिहून घ्या एक असेल. Okay, now expand this bracket. It's equal to p c 0 x raised to p 1 raised to 0 means 1 plus p c1 into x raised to p minus 1 into 1 raised to 1. Okay, आता इथं 1 raised to 1 काय घ्या, काही एकच येईल. 1 raised to 0, 1 raised to 1, 1 square, 1 cube, 1 in. So there is no need to write this one. Okay, plus p c2 x raised to p minus 2 plus up to so on. P c, last one is p p into x raised to p minus p is 0. Okay, and 1 raised to p is 1, and this minus 1 as it is, divided by x. Okay, any doubt up to here?
No, sir.
Okay. We know that value of PCP is equal to 1. कसं करतात ते फॅक्टोरियल? NC 0 असेल तर NC समजा इथे 2 असेल. कशी काय असते व्हॅल्यूची? n फॅक्टोरियल अपॉन 2 फॅक्टोरियल इंटू n मायनस 2 फॅक्टोरियल. हो की नाही? Okay. Wait a minute. Okay, so what is the value of PC0? PC0
1.
is equal to P factorial upon P minus 0 factorial is P factorial, and 0 factorial is 1. So here we get 1. So first coefficient is 1 x raised to P. Okay. Plus PC1. What is the value of PC1? P factorial upon p minus 1 factorial, and 1 factorial is 1, so you will get only p. Okay, p into p minus 1 factorial. Okay, this one, and p minus 1 get cancelled factorial, so only remains p into x raised to p minus 1. Okay, in doubt?
No, sir.
Similarly,
No, sir.
pc2 pc2 value का yield p factorial upon 2 factorial into p minus 2 factorial. Okay, म्हणजेच काय येईल यात? p into p minus 1 divided by 2. Okay, 2 factorial is 2 into x raised to p minus 2 up to so on, plus pcp किती येणार? p factorial upon p factorial get cancelled, 1, only 1, x raised to 0 is 1, and this is minus 1, so this plus 1 and minus 1 get cancelled, divided by x. Okay, any doubt?
No, sir.
Okay, look at it, is equal to x raised to p divided by x, so this is x raised to p minus 1 plus p into x raised to p minus 2. Okay, into p into p minus 1 divided by 2 into x raised to p minus 3. Okay, and at last ह्याच्या आधीची टर्म काय असेल? p c p minus 1. Okay, so what is the value of this one is p factorial upon p minus 1 factorial upon 1 factorial. Okay, ह्याच्यात नाही मायनस केली किंवा नाही येईल ना, सो हे गेट ओनली p, सो लास्ट व्हॅल्यू इज p प्लस p, ह्याच्या आधीची टर्म इथली. ओके, and into divided by x केल्यावर काय होईल तिकडे?
X
इथे
येणार.
x असेल, इथे x raised to 1 असेल कुठेतरी, मग हा x कॅन्सल होईल, तो इथे ओनली 1 राहील. ओके, सो दिस इज दी g of x. Okay, अजून बदलूया. That is g of x is equal to x raised to p minus 1 plus p into x raised to p minus 2 plus p into p minus 1 divided by 2. This is x raised to p minus 3 up to so on. This is p. Okay, now look at here. What is the a naught? p. Okay, up to so on. हे कुठली येणार? an किती येईल? What is an? त्याचा वैभव किती येईल? 1.
1.
Okay, an minus 1 is p.
P.
an minus 2 is equal to p into p minus 1 divided by 2 up to so on. Okay, now look at here. Thus, for a prime number p, okay, हा तुमचा प्राइम आहे ना, मग हाच मी p चूज केला. फॉर a prime number p we get p divides a naught, this one. Okay, p divides a1. ह्याच्या पुढची टर्म काय येईल? त्याच ह्याच्यामध्ये येईल. हा तुमचा x a naught, हा काय असेल? कुठे a naught p. ओके, a1 पण ह्याच्या पुढची टर्म येईल, त्याच्यामध्ये पण p असेल. सो ओके, सो p divides a1 up to so on that p divides an minus 1 up to this one, an minus 1, but p does not divides an. Why? Because an value of n is 1, and also p square does not divides a naught. A naught है ना?
Yes, sir.
p square
Yes, sir.
does not divides a naught. Yes. Okay. Why? Because p square does not divides. What is the value of a naught? p. Okay, so 9 is not divides 3. Okay, for example, 25 not divides 5. Okay, hence p square does not divides p. Okay, thus by Einstein criteria, Thus, by Eisenstein criteria, g of x, which is equal to pi of pi p of x plus 1, okay, is irreducible over q. That implies pi p of x is irreducible over q. Okay, any doubt up to here? So what is
No,
the value
sir.
of pi p of x is? This one. Okay, pi p of x म्हणजे काय येईल तुमचा x raised to p minus 1 plus x raised to p minus 2. Okay, पहा एकदा पाहून घ्या व्यवस्थित. Okay, any doubt up to here? म्हणजे तुम्हाला कोणता एक्झाम्पल दिला एक समजा फॉर एक्झाम्पल x raised to 10 plus x raised to 9 up to so on x square plus x plus 1 is irreducible over q. Okay, and also irreducible over z. Z वर पण काय असेल तो irreducible असेल. Okay, why? Because z of x is the subring of p of x. Okay, theorem आहे तुमचा d of x is the subring of f of x, where f is the field of quotient of d. Okay, this is the example number 1. Second, x raised to 4 plus x cube plus x square plus x plus 1 is irreducible over q as well as z. Example number 3, x raised to 12 plus x plus 1. Okay, p minus 1 च्या फॉर्म मध्ये असेल तर तो काय असेल irreducible over q. Okay, and that polynomial is called as cycloatomic polynomial. Any doubt up to here?
No, sir.
Okay. Two more theorems are there. After that, the algebra 1 syllabus is completed. ओके, त्याच्यानंतर एक छोटा टॉपिक आहे मॉडेल आणि सब मॉडेल, त्याचे 2 डेफिनेशन आहेत. ओके, ते आतापर्यंत कधी एक्झामला विचारलेलं नाही काही नाही. टेक्स्टबुक मध्ये वाचाल तर कळून जाईल तुम्हाला आयडियल सर्किट त्याचे डेफिनेशन आहे. ओके, मॉडेल अँड सब मॉडेल. नेक्स्ट थिअरम, let f of x the polynomial belongs to z of x. Okay, and b the primitive polynomial if f of x is reducible over q. If f of x is reducible over q, then f of x is reducible over z. Okay, look at here. Proof. Let f of x is reducible over q, that is in q of x. Okay, याचाच अर्थ काय q of x in q of x. Hence here we write f of x is equal to g of x into h of x. Why? Because f of x is reducible and that elements g of x and h of x belongs to q of x. Okay, where g of x and h of x are non-constant polynomial of lower degree than f of x, of lower degree than f of x. Okay, any doubt up to here?
No, sir.
Okay, we have to do that. Let f of x be the primitive polynomial. If f of x is reducible over q, then f of x is reducible over z. ओके जर q वर तुमचा इरिड्युसिबल असेल पॉलिनॉमियल तर तो ऑटोमॅटिक z वर पण रिड्युसिबल होईल. ओके now implies I can write f of x is equal to a upon b into g1 of x into h1 of x. Okay, why? Where? Look at it. g1 of x and h1 of x are primitive polynomial. Okay, मागच्या लेक्चरला आपण हा थेरम पाहिलेला आहे. If f of x is equal to g of x into h of x, so we can write f of x is equal to a upon b into g1 of x into g2 of x, where g1 and g2 are primitive polynomial. Okay. Okay, but here the g of x and h of x are two members of q of x. So all the coefficients are in the form of a upon b, where a belongs to z and b belongs to also z. And g1 and h1 now here. The two polynomials which are primitive and r belongs to in z of x. Okay, so these are the polynomial in z of x now. Okay, look at the result. File in the bracket as g of x and h of x belongs to q of x. Okay, what is the meaning of this one? The coefficient involved in both the coefficient, both the polynomial, both polynomial are quotient. Okay, as the g of x and h of x are the two polynomials in q of x, the coefficients are involved in the both the polynomials are in the form of quotient. Okay, and of the form r upon s. Okay, suppose r, and where this r belongs to r and s belongs to z. Okay, so hence by clearing the denominator, by clearing the denominator, by clearing the denominator and taking the greatest common divisor. Greatest common divisor, we get equation number 1. What is the equation number 1? This one. F of x is equal to okay. So we get the equation number 1. And remaining polynomial are primitive polynomial, and that implies remaining polynomial are primitive polynomial. ओके, तेही नाही समजलं तर और अजून एक रीजन आहे. और वी कॅन राईट g of x is equal to g dash of x upon a. Okay, we seen in the previous theorem. So and h of x we can write in the form of h dash of x upon a2. Okay, suppose this is a1 and this is a2. So that what is the g of x into h of x now? g dash of x into h dash of x upon a1 a2. G dash of x upon a1 into a2. Okay, and denote this a1 into a2 is equal to b2. So this is g dash of x into h dash of x is equal to b. The product of a1 a2 is nothing but b. Okay, now take the greatest common divisor. Okay, c1 and c2 from g dash and h dash. Okay, now take non-zero greatest common divisor c1 and c2 from g dash of x and h dash of x. Okay, so as c1 and c2 are non-zero, they are units in set. Okay, so that implies g of x into h of x is equal to c1 into g1 of x, c2 into, okay, this is h1 of x divided by b, and that c1 into c2 upon b is c1 into c2 is equal to a upon b, so it is g1 of x into h1 of x. Okay, as GCD are units, g1 and g2 are primitive polynomials. Okay, so this is the g of x into h of x. Okay, ते पाहिलेलं आहे आपण ते any two polynomial we can write in the form of g dash upon a1 and h is equal to h dash upon a2. Okay, ते नाही समजलं हे बघा. As g1 and g2, g and h are the two members of q of x. The coefficients are involved in g and h are in the form of r by s. Okay, so by clearing the denominator by taking the greatest common divisor, we get equation number 1, this one. ओके, g1 मधला प्रत्येक कोएफिशिएंट काय असेल, r बाय s चा फॉर्म असेल. जे डिनॉमिनेटरला आहे त्याचा प्रत्येकाचा ग्रेटेस्ट कॉमन डिवायझर घ्यायचा आणि काय करायचं, त्या पॉलिनॉमियलला न्यूमरेटरला आणि ह्याला काय करायचं, मल्टिप्लाय करायचं, एक ग्रेटेस्ट कॉमन डिवायझर. ओके, ॲट लास्ट वी गेट दिस वन, a upon b is equal to g1 of x into h1 of x. Oh, okay, instead of g we can write g1. Okay, instead of h we can write h1. Okay, and where g1 and h1 are काय असतील ते primitive polynomial. Okay, so that implies, so what we get now here, f of x is equal to a upon b into g1 of x into h1 of x. Okay, so that implies b of x, b into f1 of x into is equal to a into g1 of x into h1 of x as the product of, okay, here g1 and h1 are primitive polynomials. The product of two polynomial is a primitive polynomial by Gauss theorem. Primitive polynomial g1 of x into h1 of x is also primitive. Okay, and f of x, sorry, f of x है ना, f of x is also given to us a primitive polynomial. Okay, also primitive polynomial, and comparing the left hand side primitive, right hand side also primitive, hence comparing the contents we get p is equal to plus or minus 1 into a. Okay, plus or minus 1 ka, because we get b into u into a, b is equal to u into a. where u is units. Okay, unit in z. Okay, but what is the unit in z is plus or minus 1.
Plus or
Okay, so that
minus.
implies b is equal to plus or minus a, or a is equal to plus or minus b. Okay, so hence by putting the value of b, a is equal to plus or minus b in this equation, equation number 2, suppose this is. Now putting the value of a is equal to plus minus b. So what we get here then, b into f of x is equal to plus minus b into g1 of x into h1 of x. Okay, by cancelling the b by left cancellation rule, implies f of x, is equal to g1 of x into h1 of x, where g1 of x and h1 of x belongs to here z of x. ओके, आता या g1 आणि h1 मधले जे कोएफिशियंट्स आहेत ते कसे आहेत, क्वोशंट फॉर्म मध्ये नाही आहेत, ते त्यांचा डिनॉमिनेटर 1 आहे. ओके, hence implies if f of x belongs to z of x, the primitive, and if f of x is reducible over q, it implies f of x is reducible over z. Okay, any doubt up to here?
No, sir.
F of x belongs to z of x with any polynomial where the coefficients of f of x are belongs to z. Okay, with a primitive polynomial. What is the primitive means? All the divisors, all the common divisors of that coefficient or coefficient of f of x are units in z. Okay, so if f of x is equal to f of x is the reducible over q, then it f of x is reducible over z. Okay. Now the last theorem of our syllabus, last theorem. Okay. Let f of x is equal to a naught plus a1 of x plus a2 of x squared plus up to so on an minus 1 x raised to n minus 1 plus an of x raised to n. Okay, be the polynomial belongs to z of x. Okay, it is the coefficients of all the coefficients of polynomial a naught a1 are belongs to this set. Okay, be a monic polynomial. What is the meaning of monic polynomial?
Leading coefficient must be 1.
Leading coefficient कोण आहे इथे मग?
A raised to n is equal to 1 पाहिजे.
an किती असायला पाहिजे तुमचा? लीडिंग कोएफिशिएंट an आहे, हो की नाही? सो लीडिंग कोएफिशिएंट किती असायला पाहिजे ते 1. Okay, so f of x is equal to a naught plus a1 of x plus a2 of x square plus up to so on 1 into x raised to n, be the monic polynomial. If f of x has a root a belongs to q, okay, field of rational number, then a belongs to z and that a divides a naught. Okay, बघा स्टेटमेंट काय सांगतो नीट लक्षात. f of x has a root a. रूट आहे म्हणजे काय, तिथे तुमचा f of a is equal to 0 आहे. ओके, जर असा असेल तर तो a हा काय असायला पाहिजे, इंटीजर असायला पाहिजे. अँड तो जो ए आहे या ए नॉटला काय करायला पाहिजे, डिवाइड करायला पाहिजे. ओके. आणि कंडिशन काय तुमची, एफ ऑफ एक्स विथ द मोनिक पॉलिनॉमियल. व्हॉट इज द मीनिंग ऑफ मोनिक पॉलिनॉमियल? द लीडिंग कोएफिशिएंट इज 1. Okay. So, now look at the proof. Let f of x, let f of x has a root a belongs to q. Okay, where that f of x belongs to z of x. Okay, all the coefficients are belongs to z. Now, what is given to us? F of x has a root a belongs to q. What is implied? F of a is equal to 0. Okay, and also given that now a belongs to the q मध्ये असेल. Okay, if a belongs to q असेल, that implies a is equal to b upon c. Okay, quotient form मध्ये असेल, where b and c are relatively prime elements in set. Okay, that is the GCD of A and B किती असायला पाहिजे तुमचा?
Unit.
1. Okay, any doubt up to here?
No, sir.
Okay. समजा तुमचा A जर 2Q मध्ये आहे, yes, is rational. So 2 we can write is equal to 6 by 2. But here the GCD of 6 and 3 is not 1. So the shortest form कधी येईल तुमचा? Relatively prime जर घेतला मी, relatively prime elements in Z. Okay, that is a GCD of AB is equal to 1 जर घेतला तर हा किती येईल फॉर्म? 2 upon 1. ओके, मग ह्याच्या न्यूमरेटर आणि डिनॉमिनेटर मधनं कॉमन काहीच निघणार नाही. त्याचाच अर्थ काय? आर रिलेटिव्हली प्राईम एलिमेंट्स इन झेड. याचा अर्थ काय? या बी मधून आणि सी मधून कोणताही कॉमन डिवायझर बाहेर येणार नाहीये, कॉमन फॅक्टर बाहेर येणार नाहीये याचा अर्थ. ओके ओके.
Yes, sir.
जर प्राईम एलिमेंट नसतील तर काय झाला असता, ह्याचा शॉर्टेस्ट फॉर्म आला नसता तो. ओके, त्याच्यामध्ये काही न्यूमरेटर आणि डिनॉमिनेटर मध्ये काहीतरी कॉमन फॅक्टर राहिला असता. ए आणि बी हा रिलेटिव्हली प्राईम एलिमेंट्स आहेत म्हणजे काय, तो शॉर्टेस्ट फॉर्म, त्याच्यातनं पुन्हा कोणताही फॅक्टर येणार नाहीये कॉमन. ओके, इफ ए बिलॉंग्स टू क्यू then what is the form of A is equal to B upon C, where B and C are relatively prime elements in Z and GCD of AB is equal to 1. Okay, thus we have f of A is equal to 0. What it implies? What is the value of A? F of B upon C is equal to 0. Okay, now put in place of x b upon c in the given polynomial f of x, this one. Okay, so what we have then? Therefore a naught plus a1x, so that is a1a b upon c plus a2 into b upon c into square c raised to square bracket square plus up to so on an minus 1 into b upon c bracket raised to n minus 1 plus b upon c bracket raised to n is equal to 0. Okay, any doubt up to here?
No, sir.
Now multiply both sides by c raised to n minus 1. Multiply both sides by c raised to n minus 1. Okay, so we obtain, we get a naught into c raised to n minus 1 plus look at here, a1 into b into c raised to n minus 2. Okay, c raised to n minus 1 upon c. Here we get c raised to n minus 2 plus a2 into b into c raised to n minus 3 plus up to so on a n minus 1 into b raised to n minus b raised to n minus 1 into c raised to n minus 1, and this c raised to n minus 1 get cancelled, plus, which is equal to, take this towards the left side now, minus b raised to n into काय upon c. ओके, c raised to n आहे इथे खाली, आणि इथं काय करतो आपण, c raised to n minus 1 is equal to काय येईल, b upon c येईल ना.
Yes, sir.
Take towards this right side, so here we get minus b raised to n upon c. Okay, any doubt up to here?
No, sir.
2 question number solve दिलाय. Okay, Q is the equation number 1. That's equation number 1. A is equal to b upon c. Okay, as, look at here, as small f of x belongs to capital Z of x. Okay, it's given to us. Small f of x is belongs to capital Z of x. Okay, that implies a naught, a1 to so on, an minus 1 r belongs to Z, and b कशातून आहे, c, b and c belongs to Z. Okay, here that implies the LHS, left hand side of the equation, this one. Okay, the left hand side LHS is member of Z. Why? हा तुमचा मेंबर, झेडचा मेंबर, हा पण झेडचा मेंबर, यांचा प्रोडक्ट कुठे जाईल, तो पण झेड मध्येच जाईल. ओके, since Z is closed under addition and multiplication, since Z is closed under addition and multiplication, that implies the left hand side तुमचा Z मध्ये असेल, तर राइट हँड साइड काय असेल, मायनस बी. दॅट इम्प्लाइज, आधी लिहा, बी, that implies right hand side is also member of Z. Okay, what is the right hand side? Minus b raised to n divided by c belongs to Z. तर मायनस बी रेस टू एन अपॉन सी हे जर झेड मध्ये असेल तर काय होईल, बी रेस टू एन अपॉन सी ऑल्सो बिलॉंग्स टू झेड. ओके, okay, now b raised to n upon c belongs to Z. The nature of element in Z are not quotient. Okay, are not quotient, म्हणजे हा तुमचा quotient नसेल. Quotient नसेल म्हणजे काय असेल मग, that implies c is equal to, what is the value of c then, plus or minus 1. Okay, any doubt up to here?
No, sir.
Now put this value of c, this value of c, okay, in equation 1. Okay, what is 1? A is equal to b upon c, so that implies a is equal to plus or minus b, where b belongs to Z. Okay, b तुमचा कशातला Z आहे, that implies that a also belongs to Z. Okay, hence from 2 we have, from equation 2 we have, look at it, equation number 2. Okay, c ची व्हॅल्यू काय झाली, प्लस किंवा मायनस 1. ओके, प्लस घ्या मायनस घ्या, काय येईल बघा इथं काय, a naught plus a1b this b plus a2b square plus up to so on plus, जर मायनस घेतलं तर काय होईल, मायनस एन कॉमन घेऊन राईट हँडला साईड पाठवतो. ओके, so this is an minus 1 into b raised to n minus 1 is equal to plus minus b raised to n. Okay, that implies a naught is equal to minus b, wait a minute, transfer. Okay, so a naught into हा येणार तिथेच ठेवला आणि हा सगळा काय केला तिकडे शिफ्ट केला, प्लस मायनस बी रेस टू एन आहे तसाच, मायनस ए वन बी प्लस सॉरी मायनस ए टू बी स्क्वेअर मायनस अप टू सो ऑन इज मायनस एज इट इज ए एन मायनस वन to b raised to n minus 1. That implies a naught is equal to, take b common from this, b, okay, into bracket minus b column, okay, minus b. So here we get, here we have plus a1 plus a2b, okay, plus up to so on plus an minus 1 into b raised to n minus 1 plus minus b raised to n minus 1. Okay, यातनं एक b कॉमन बाहेर गेला. Now the right hand side, okay, bracket is a member of Z. हा तुमचा काय, member of Z. Okay, and a naught and b are also member of Z. पहा इथे हा पॉलिनॉमियल कशातला आहे, Z of x, म्हणजे हा a naught कोणता मेंबर आहे, Z चा मेंबर आहे. ओके, इथे काय प्रूव्ह केलंय आपण, बी हा कोणता मेंबर आहे, आधीपासूनच बी बिलॉंग्स टू झेड आहे. ओके, सो हियर a naught and b also belongs to z. So that implies जर असा फॉर्म असेल a naught is equal to b into c असेल तर काय असतो, b divides a naught. So that here implies b divides a naught. ओके, हा तुमचा पूर्ण इंटिजर, i इंटिजर, हा इंटिजर. And what it implies, that b divides a naught. That implies that b divides a naught. Okay, b divides a naught. Okay, so this is the equation number 3rd. Now that implies as a is equal to b upon c, okay, which is equal to b is equal to, what is the value of c, we get plus or minus 1. What is the value of a is plus or minus b naught. Okay, so that implies if you get here b divides a naught, this one, that implies minus b also divides a naught, then याची व्हॅल्यू काय, प्लस मायनस बी. बी पण एला डिवाइड, ए नॉटला डिवाइड करतोय, मायनस बी पण एला ए नॉटला डिवाइड करतोय. ओके, सो देन प्लस मायनस बी also divides a naught. That implies a divides a naught. Okay, so this is the proof of the theorem. Any doubt? काही डाउट्स असतील तर विचारू शकता. एकदा वाचलं की समजून जाईल. Let f of x be the any polynomial belongs to z of x be a monic polynomial. Okay, if f of x has a root a belongs to q, then a belongs to z. तुमचा a कसा असेल, z मधला असेल. Okay, and then a divides a naught. Okay, any doubt? Okay, for example, हा तुमचा एफ ऑफ एक्स आहे. ओके, त्याचा रूट कधी येईल? एफ ऑफ ए झिरो कधी येईल? इफ अँड लिव इज इक्वल टू 1/2, एक्स इज इक्वल टू, ओके, एफ ऑफ एक्स इज इक्वल टू 0 कधी येईल? जेव्हा एक्स तर 1/2 असेल तर. म्हणजे 1/2 हा तर कधी आहे तुमचा? रूट आहे कोणाचा? या पॉलिनॉमियल. पण हा पॉलिनॉमियल आहे का मोनिक? मोनिक पॉलिनॉमियल आहे का? नाही. ओके, जर मोनिक पॉलिनॉमियल घेतला तर काय येईल मग? एक्स इज इक्वल टू 1. मग तो हा रूट कशामध्ये जातोय तेव्हा? झेड मध्ये जातो. ओके, एनी डाउट?
No, sir.
So this is our last theorem of algebra 1, ring theory. Okay, so here the ends of the ring theory and our syllabus of algebra 1. From tomorrow onwards, we are going to see differential equation chapter number 3. Okay, any doubt up to here? काही doubts असतील तर विचारू शकता आतापर्यंतच्या syllabus मध्ये.